So we're continuing our lesson on 3.4, that idea of linear programming. We've just reviewed all of the steps: graphing the inequalities, locating that feasible region, finding the vertices, and then evaluating each vertex in your objective function to find your max and mins. What's different today is that we have to come up with our own constraints in objective function. Okay, so it's going to be a word problem, and you're going to be asked to figure out all of those inequalities. Okay, I am asking that you use a ruler. Your lines need to be very accurate in order to find the vertices. Okay, all right, so the process when you have a word problem, you're going to create a chart, basically a table, to organize all of your data. The columns should be the products being discussed. So for example, if it's talking about we're going to make some tables and chairs, okay, tables would be one column, chairs would be another column. The things that they're telling you information about, like how much material is required to make a table, how much time is required, that type of thing, those are going to be your row headings. Okay? Then you'll also want one column at the end for your total. So you're basically going to set up a chart like this. Okay? In our first example here, it says you're screen printing t-shirts and sweatshirts to sell at a blues festival, and you're working with the following constraints. You have at most 20 hours to make the shirts. Okay? That's a time constraint, right? So we have something about time. Then it says we want to spend no more than $600 on supplies. We have a money limit. Okay? And then it says we want to have at least 50 items to sell. So how many, the quantity or number of things, there's a limitation about that. Okay? Over here on the tags for the shirts, it says that to make the t-shirt, it takes 10 minutes. It costs $6 for supplies, and we make a $6 profit. For the sweatshirts, it takes 30 minutes to make them. Supplies are $20, and we make a $20 profit. So they're giving you a whole bunch of information. You need to organize it. All right, and setting up a chart is going to be, or a table is going to be the best way to do that. So what do we know about the t-shirts in terms of how many minutes does it take to make one? What did it say? 10 minutes. Okay. How about sweatshirts? How many minutes does it take to make those? 30. Okay, now, what is the total number of minutes that we have available? So be careful, because it gave us what? Hours? 20 hours would be equivalent to how many minutes? Right? It says we have at most 20 hours. That means my total can't go over 1,200 minutes. Does that make sense? So I'm going to put less than or equal to 1,200 here. In terms of the number of items, what are we told? We want to have at least 50. Okay, so total number of items, I want to be at least 50, greater than or equal to 50. What does it cost to make them? It says a t-shirt costs $4 and sweatshirts cost me $20 to make. And how much money do I have available to buy all that supplies? No more than 600, so we would be less than or equal to 600? Does that make sense? Okay. On those little tags by the shirts, it also tells me something about the profit. For this t-shirt, it says we make $6 in profit. Sweatshirts, we make 20. Okay? Now, do we have a total profit? No. What did it tell us? We want to maximize our profit, right? And remember from yesterday, the item that you're trying to maximize or minimize, that's your objective function, right? So I want you to put a line through here. because everything above that line pertains to my constraints. They're limitations that I have. I don't have a limitation on profit, right? I'm trying to go forever on profit. So I'm going to use a P here for my profit. But I want to be very clear. These are your constraints. Okay? This bottom one is your objective function. Okay? We do not graph the objective function. All right. In order to write out the inequalities, you have it set up. It's basically staring at you. It's just waiting for you to write them. What we have to do is define our two variables. So remember we said the column headings are the things you're making, right? So I'm going to say X equals the number of t-shirts and Y equals the number of sweatshirts. So for the first one, in terms of the time constraint, every X that we make is going to take me 10 minutes. Every Y that I make is going to take me 30 minutes, right? So basically what you're doing is every column here, these are all my X's, these are all my Y's. Okay? And if we add the t-shirts and sweatshirts together, it has to be under my total. Does that make sense? So by organizing them in a chart this way, it's really all set up to just give you the constraints. So the first one I'm going to write is 10x plus 30y has to be less than or equal to 1200. Okay? The second one, I have x plus y has to be greater than or equal to 50. And my third one, my cost, I have 4x plus 20y has to be less than or equal to 600. Okay. There are two implied constraints. We talked about these yesterday a little bit. What's the implied constraint here? Yes, x has to be greater than or equal to 0. I'm trying to color code here. Because we can't make negative t-shirts or sweatshirts, right? We can make none. We could say I'm not going to make any t-shirts, I'm going to make all sweatshirts, but we can't make negative. So these two combined basically tell me that I am in quadrant 1. Yes? So as long as you tell me that, hey, this means quadrant 1, you don't have to graph those. So we're going to set up our graph paper here just to be table or quadrant 1. And we said X was t-shirts. And we said Y was sweatshirts. Now, the bottom of my chart here, where we have profit, remember we said that's our objective function. So I'm going to write that down here in my bottom table. Profit equals, what did we have? What was it, 4x? No, 6x plus 20y. Okay, I'm not going to graph that one. All right, so we need to get all of these constraints graphed. Before we start plotting any points, I would strongly recommend that you figure out your x and y intercepts for each equation so that you can tell how to space out your graph. Okay, we don't want it to be super tiny because we're not going to be able to read it. So for our blue line, it's in standard form, so we're going to do our intercept method for graphing. If we put in 0 for y, 10 times what gives us 1200? What do we get? 120? And if we put 0 in for x, 30 times what gives me 1200? 1200 divided by 30. Take a 0 off. 120 divided by 3. Okay. All right, for the green one, if I put 0 in for y, I get 50. If I put 0 in for x, I get 50. Okay, and then for red, if I put 0 in for y, 4 times what gives me 600, or 600 divided by 4? 600 divided by 4. Grab your calculators, guys. Let's go. 600 divided by 4. If you're not going to do it in your head, you got to have a calculator. Thank you. Okay, if we put 0 in for x, 600 divided by 20. Okay. So I always make those little t-charts before I start graphing anything because I need to figure out how to space out my tick marks. We have to get up to a maximum number here of 150 for x. So what do you think we should do for our x-axis? If we went by tens, we'd need 15 tick marks, right? Do we have 15 tick marks? I think it's a 20 by 20 grid. Okay, so we can do by tens. Okay. Now, we can do the same thing for the other axis. We could spread it out a little bit further because we only have to get up to 50. Okay, but it's your choice. If you want to just keep everything by 10 so it's a little easier to count, you can do that. All right. So our blue one, we need 120 for x. That means 12 tick marks. All right, and then we need 40 for y. Would we be shading above or below that line? Remember, the quick way is to just test the origin. If you put 0, 0 in, does it work? Are we under 1300? Or sorry, 1200? Yeah. So we're shading below. Okay. What's next? Green. We need 50 and 50. Shading above or below? This time we want to be greater than or equal to 50, right? Does the origin get us something greater than 50? No. So this time we want to be shading above. And then for the red, we want to be on, let's see, 150 for x and 30 for y. All right. Shading above or below the red line? Does the origin work or not? Okay, so we're shading below. So we have to be in quadrant 1. We need to be underneath blue and red, but above green. So the shaded part that overlaps would be in this section in here. We good with that? All right. So we've written our constraints, we've written our objective function, we've graphed all the constraints, we've found our feasible region. What's the next thing we have to do? Find those vertices. Okay. Some of them are a little more obvious than others. For example, this is a point we actually plotted, right? So we know that is what? What are the coordinates here? 50, 0. Okay. We've got a spot here. That was at 12, so 120, 0. Now, we have two other spots. We have one here where green and red lines intersect, and we have one here where green and blue intersect. We could make a guess and check it in the two colored equations that are supposed to cross there, or we can solve the system. For this first one, I'm going to go ahead and solve the system just so you can see that process, because not always will you be able to make an accurate guess. Okay. So we are looking, let's start with green and red intersecting. Okay, so we have x plus y has to be greater than or equal to 50. Let's just look at where they actually cross. So equals 50. And red was 4x plus 20y equaling 600. How would we solve that system? What could we do? So you're thinking substitution? All right, so solve the top one for an x or a y and substitute it into the other one. That works. What else could we do? If we wanted to use the elimination method, what could we do? Okay, so how many would do elimination? When you look at it, would you choose elimination? How many would choose substitution? Okay, it's about the same. So let's do elimination. So let's times this whole thing by -4. So we end up with -4x minus 4y equaling -200. And then we're combining it with this bottom equation. We end up with 16y having to equal 400. Divide both by 4, you get 4y equals 100. 4 times what's 100? Come on, guys, use your brain. 25, there we go. Okay, now plugging it back in. If y is 25, what do we have to add to it to get 50? Okay, so my ordered pair that I'm coming up with is 25, 25. Does that look realistic for my graph, knowing that we were going by tens? Is it crossing at about 25, 25? Yes. Okay. The last vertex is the one where where red and blue intersect. Okay, this point here. So how would we solve that? What did we say? Red and blue. So we have 10x plus 30y is less than or equal to 1200. Again, we're going to just focus on the equal ones. 4x plus 20y equals 600. So now what would we have to do if we were going to use elimination? What would we do? This one would not work well with substitution, right? We'd get a lot of fractions. It can be done. It's just not fun. All right. So if we times the top, let's say we're getting rid of the x's. Could we get these to be 20s? Okay, so let's times the top by 2 and the bottom by -5. Okay, so we get 20x plus 60y equaling 2400. We get -20x minus 100y equaling negative 3,000. Combining those equations, we get negative 40y equaling negative 600. Okay, the two negatives will drop out. You could take a 0 off both sides. So think of 60 divided by 4. What do we get? 15. All right, so y is 15. And then if we plug that back in for one of our y's, it doesn't matter which one. Let's say we plug it in there. Then we've got 4x plus 20 times 15 equaling 600. What's 20 times 15? 300. Subtract 300 over. So 4x has to be the other 300. What's 300 divided by 4? Okay. So we're getting the point x being 75 and y being 15. Does that fit our picture? 50, 60, 7, this is about 75. Yes? And about 15 over here? Okay. So now, what do we do once we have all of these vertices? What's that last step? Yes, evaluate the objective function. So we're going to plug them in. So P equals, we said our profit on every t-shirt was 6 and every sweatshirt was 20. Right? So we're basically just going to plug our xy's into that expression. So go ahead and use your calculators if you want. Let's get totals for all 4 of these. All right, check the first two. I'm getting 300 and 720. Agreed? Yes? Okay, what did you get for the 25-25 option? 650. And for the bottom one? Okay, now remember, this is how much profit I make at each of those different combinations, right? And I want to maximize my profit, so what am I going to pick? The 750 option, right? That's going to give me the most money. Now, yesterday I said you would say my maximum is 750 at the point 75.15, right? But now we have a context. We know what the 75 stands for and we know what the 15 stands for. So you're actually going to write out the answer using that context. So we can make a maximum profit of $750 by doing what? By selling 75 t-shirts and 15 sweatshirts. Okay. The next example, we're not going to do the whole thing. It's just telling you we're going to make one slight change to this problem. What is the change they said? What if it only takes us 20 minutes to make a sweatshirt? So going back up to our chart here, we would be changing this 30, right, to a 20. So my top one, which in my case is my blue inequality, my blue line would change. Yes? Would that affect my vertices? Yes. So I'm now getting different vertice options. I'm going to get different amounts of profit possibilities, right? It would change everything a little bit. Okay. All right, so let's move on to the next one. So we're not going to do that one. All right, so problem 6. It says a furniture manufacturer makes chairs and sofas from prepackaged parts. A chair requires 2 boxes of wood, 4 boxes of stuffing, 1 box of fabric. A sofa requires 3 boxes of wood, 3 boxes of stuffing, and 2 boxes of fabric. The packages arrive once a week. The manufacturer has room to store 1,300 packages of wood, 2,000 packages of stuffing, and 800 packages of fabric. They make a profit of $200 per chair and $350 per sofa. How many chairs and how many sofas should the manufacturer make each week to maximize the profit? So what would we put in the top of our columns? And I'm asking you that. I know the chart's already in your notes packet. But if you are working on a word problem from homework, right, you're not going to have that chart made. So think about what they're asking. How many sofas? How many chairs? That's going to be your column headings. Okay, sofas and chairs. So let's let X equal the number of chairs and Y equal the number of sofas. Okay. Then we're going to fill in our chart. What do we know about the chair? It takes 2 boxes of wood, 4 boxes of stuffing, and 1 box of fabric. Okay. What about the sofa? What are my numbers? 3. Okay, 3, 3, and 2. All right. How much room do we have available? We can store. Okay. Now, what kind of inequality would we put in there? Yes, less than or equal to. We can't go over 1,300. We don't have the room for it. Okay. Stuffing. We've got 2,000, space for 2,000. And fabric, we have space for 800. So all of those are going to be less than or equal to's. Does that make sense? Okay. Then it says we are trying to maximize our profit. So right there, ding, 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 bells should be going off in your head. You're maximizing profit. That means profit is your objective function, right? That's what your objective is, to maximize profit. So I'm going to put a line here. The top ones will get me my constraints. The bottom one is my objective function. How much profit did we make on a chair? $200. How much on a sofa? $350. I'm just going to use a P for profit. Okay. And then remember, we're just filling in our columns. So my first column are all my X's. My second column is all my Y's. And I want to add them up to have them equal that total. Okay. So I'm going to bring that objective function down here. P equals 200x plus 350y. That's what I'll use at the end. Okay, my constraints. I have 2x plus 3y has to be less than or equal to 1,300. I have 4x plus 3y is less than or equal to 2,000. And x plus 2y is less than or equal to 800. And what are the two that you have to add in there? Yes. Okay, so again, those bottom two, just tell me that I'm in quadrant 1. Okay. So we're going to split this one up a little bit to save some time. So first 3 tables over there against the wall, I want you to figure out the x and y intercepts for the blue one. Okay. Middle group in here, I want you guys to do green. And you guys over here, I want you to do red. Okay? Yes, do green. All right, what did we get for blue? Okay. All right, green? All right, and then red. Red. $433 and 1/3. Okay, so we need to get up to 500, 800 actually. We need to get up to 800. So if we went by 50s, does that seem reasonable? Okay. And we're going to do chairs. That was X, sofas was Y. All right. So for red, I'm going to do red first since I have that pen. 800 would be here. 400 would be here. Okay, so you've got our lines drawn. Are we shading above or below? On those lines, above or below? Below on everything? Okay, so our feasible area then would be down in here? Yes or no? All right. So finding our vertices. We've got the origin as 1. We have a point here. What was that red one? 0, 400. We have this green point here, and that was at 500, 0. And the other two are a little harder to tell, right? So we've got a blue and red one. Yes? Intersecting, and we have a green and blue? Intersecting. Can we make a guess as to what we think those are? Yes or no? Yes? Okay, so let's look at this taller one here, the higher one. It looks like it's 200, 300? Okay, let's try that. Now, when I mean try it, I mean you have to go back to the two colors that are intersecting and see if it works in those two inequalities. So that was red and blue. And then red. So we're saying that 200 is my x and 300 is my y. Does it make those two statements true? 2 times 200 is 400. 3 times 300 is 900. Does that add up to, sorry, too many zeros, add up to 1300? Okay. In our second one, we have 200 plus 600 to get 800. So is it working? Yes. How about the other one? Blue and green. What does it look like? If you had to estimate it from the graph. Remember, our tick marks are going by 50s. 100, 200, 300. This should be 350. And over to y, 200. Okay, so let's check that one. 350, 200. And we said that was blue and green. So I'm plugging it into my blue equation and into my green equation. So top one, 2 times 350 is 700. 3 times 200 is 600. 700 plus 600 is 1300. In the bottom one, 4 times 350 would be 1400. Plus another 600 would get me my 2000. Okay? So if you can accurately guess those vertices, I'm fine with you just checking them and making sure they work. If you're having a hard time guessing the point, then solve it like we did on the first one. Okay? All right. Go ahead and split it up. Let's see. Well, what happens if we do 0, 0? Yeah, our profit's 0. So tables over there, you guys do a 0, 400. Middle tables here, 500, 0. Over here, 200, 300. And over on the end here, 350, 200. Okay, so we filled in our chart. We said if we make no chairs and sofas, we make no profit. If we make 0 chairs but 400 sofas, what did we come up with? 0, 400. 140,000? Okay. How about if we made 500 chairs and no sofas? 100,000? And if we make 200 chairs and 300 sofas? 140 again? And our last combination? 145,000? Yes? Okay. So, which one gets us the maximum profit? Which one? The last one. So we would say maximum profit is 145,000 when we make 350 chairs and 200 sofas. Yes. Do I have them flipped around? Are you agreeing that or not? You are right. These should be reversed. Is that where our mistake was? Okay, so we want how many? 200 chairs and 300 sofas? Does that make sense? Okay. All right, looking at our last one, we are just going to set it up. We're not going to do all the graphing, okay? So, looking at this one, we're making some orangeade and some berry fruity, okay? It says it takes 2.5 quarts of orange juice to make the orangeade and 1.5 quarts of raspberry juice. For the berry fruity, it takes 1 quart of orange juice and 3 quarts of raspberry. And our profit, 50 cents on orangeade and 40 cents on the berry fruity. Okay? It says the company has 500 quarts of orange juice and 600 quarts of raspberry juice. So we filled in our chart. So what are my constraints going to be? How would I write them out? Come on, guys. Thank you. Somebody else? What's my next one? Less than or equal to 600? Yes? And then my two implied ones? Right? Can't make negative juice. Okay. What would my objective function be? .5x plus 0.4y? Are we good with that process? Okay. So your homework, you have 4 questions to do from your book, 13, 14, 16, and 20. You are going to do the whole process for those 4 problems. Okay? Then I have 3 questions on a worksheet that I just want you to set up the constraints in the objective function like we did on the last example. Does that make sense?